For 12.6, we're going to go over scatter plots, correlation, and regression lines. Let's take a look at our graphic here. So we have what looks like a quadrant number 1 on our coordinate system. And the reason why I say that is because our x-axis, which measures the high school GPA, this is my x-axis right here, that is going from +2 to a +4. A GPA of 2 is saying that they're recording everyone that made a C through an ABC. Same thing with the university GPA, which this is my y-axis here. All right, again, this starts at a 2 and it goes up to a 4. So when the x values are positive and the y values are positive, you are in quadrant number 1. If you recall, we had a coordinate system that looks like x and y. All right, and this scatter plot is all over here in the quadrant number 1, what I call Q1. It would not make sense for you to go in and present a graphic that looks like this because you have all the wasted space for these quadrants that are not needed. All right, so that points on here, all the little black specks, those are your scatter, that's your points called scatter plot. All right, without the line, just the little points are called a scatter plot. The line, the red line, that is called a linear regression line. The linear regression line is referring to the line of best fit. We're going to draw a line that goes to as close to as many points as possible. And we'll be using a calculator to do this. So make sure you're prepared with your Casio 115 ES Plus calculator and the instructions for that. So we do a linear regression line to see if our x-axis has any type of relation with our y-axis. So we want to see if our x and y variables have a relation, whether it's positive or negative or no relation at all. And that is why we're going to be studying correlation. So this graphical image is measuring the years of education in relation to the score on a test measuring prejudice. So we have a scatter plot. Those are the points that you see on the graph. And then we also have a blue line, which is a linear regression. You can see that as we go from left to right, it slants down on the graph. So therefore, this is called a negative slope. Once again, let's review our slopes real quick. If the slope falls from left to right, this is considered a negative slope. If it is increasing from left to right, this is a positive slope. If it is a horizontal line, our slope, remember we use lowercase m for slope, is 0. If we have a vertical line, my slope is undefined. Those are the 4 different types of slopes that we could possibly have. And when we say positive, it means m is going to be a positive number. If we say negative, of course, it's a negative value. So in this case here, this has a negative slope. So as the years of education, this is what I'm understanding from this graph, as we increase in the years of education, the rating of the score on the prejudice is decreasing. This next slide is asking us to make a scatter plot for the given data. So they gave you a table up here for x and y, which are your x and y coordinates. And it says use the scatter plot to describe whether or not the variables appear to be related. All right, so we're going to go in and graph each one of these. Remember, we always start at the origin. The first ordered pair is x is 2, y is 2. So I start at the origin, I move 2 units to the right and 2 units up, and I place my dot. That is 2, 2, my ordered pair. The next ordered pair is 7, 9. So I start at the origin again, go to the right 7 units, and then I go up to 9, and I place my dot. All right, and then the next one we have is 3, 5. Start at the origin, 3 units to the right, 5 units up. So we're just going to go through each one of these and place the appropriate point on each one. I'm going to do 8, 8 next. and then 6,7. All right, so not quite beautiful, but good enough for what we're looking at. So when you place your points on there, this is called a scatter plot. All right, and you see that we're not using any of the other quadrants. Quadrant number 2, this is quadrant number 1. This is quadrant number 2, and this is quadrant 3. And we're using Roman numerals, quadrant number 4. So you can see if you had to go in and present this and make a presentation out of it, you would want to eliminate quadrants 2, 3, and 4 and zoom in on quadrant number 1 so that everyone can really see your data. All right, so on the right-hand side here, this is just what it looks like on my math lab when you plot those points. And they're asking you, do the variables appear to be related? All right, so when you think about appear to be related, you want to see, does it follow closely to maybe a positive slope or maybe perhaps a negative slope? So take a good look at your ordered pair, and if you need to, you can take like a straight edge and just kind of hold it up your pencil to your scatter plot and see if it's close. So you can see in this case here, basically for most of the points, as x increases, y increases. All right, so it has sort of a positive slope here. So I would say, do the variables appear to be related? Yes, they do. And I would answer yes for part B here. These figures are showing the scatter plots and correlation coefficient. So it says that down in the description where it says figure. And the correlation coefficient, when we're looking at the correlation coefficient, that is that lowercase r that you were seeing. Let me write this out real quick. So it is lowercase r is equal to the correlation coefficient. So let's take a look at what r is equal to versus what we see on the scatter plot. So for the A, we can see that this is calling a perfect positive correlation because r is equal to 1. All right, it's a positive one, so you think of a positive slope. If I had to draw a line of best fit, one that goes as close as possible, it looks like this is directly on that line. All the points touch the line, so therefore it's called a perfect positive correlation. As x increases, y increases. All right, the next one, B, is called a strong positive correlation. And notice the number on there. It says R is approximately 0.8. All right, so once again, I'm just going to try to put a nice line in there. It's close enough. But in this case here, it is relatively a positive slope, right? We have a couple of points that are on the left and the right side of the line, but the line basically is close to most of the points. And that number 0.8 is really close to the number 1, so it's considered a strong positive. The next one we have is called a weak positive. So the correlation coefficient, R is equal to 0.3, is a positive number. All right. Again, it looks like it's going in the positive direction, but there's a lot of points that are away from the line. So it is positive, but it's called a weak positive. And this last one, you can see this is just a scatter plot where things are all over the place in that quadrant. So R is equal to 0. This one has no correlation. No correlation. We can't tell if it's positive or it's negative. All right, on the bottom graph, E, again, let's see, I'm going to try to draw this as best as I can. So you can see there's a line that kind of decreases, so it's a negative number as the correlation is. It's 0.3 with a negative sign in front. And because there are a lot of points that are away from the line, this is called a weak negative correlation. A weak negative correlation. The next one is called a strong negative correlation. Strong negative. So it's a negative 0.8 for R. And we'll just draw a line here. And you can see that If you compare the last graph to this graph, they're both negative, but more points are closer to the line, so it's considered a strong negative. And the last one is called a perfect negative correlation because R is equal to -1. So let's see if we can understand this just a little bit better. The correlation coefficient helps you determine how X is related to Y and vice versa, or if there is any type of relation between the two. In other words, as one increases, does the other one increase? Or does it have an inverse relation where one increases and the other decreases? Correlation coefficient explains the relationship. All right, so to help you out a little more, I'm going to draw a number line. Correlation coefficient, remember you can have a -1, a +1, or 0 here. And what I'll do is go halfway between each one. So this is a -0.5, and this is just a +0.5. All right, so if you have a -1, again, you are a perfect negative. If you are between -0.5 and just on the right side of that -1, that is considered a strong negative. Again, if you are on the positive 0.5 over close to 1, +1, that is a strong positive. If we are between -0.5 and 0 here, that is our negative. That's going to be our weak negative. And if we are in between 0 and 0.5, that is a weak positive. When we take a look at 0, remember our 0 here area is no correlation. So hopefully that'll help explain to you how the correlation coefficient works. So looking at this graphic, it says in which scatter plot is R approximately -0.3? So we're going to take a look at each of our graphs and see if you can decide which one it would be. We just went over that number line on the previous slide, so that should give you an idea. But let's take a look. So this first graph here looks like possibly that it is going in a positive direction. So if I had to draw a line, best fit is somewhere close and in between all those data values. But you can see there's a lot of points that are away from the line. So this would be considered a weak positive. All right, the next one here, that is a perfect negative, correct? Because it is exactly a line. And it goes in the decreasing from left to right, it's decreasing. So perfect negative. And C has, let's see if I can draw this correctly. If I draw a line, it is also a negative, but it is considered a strong negative because there are a lot of points that are real close to the line. All right, so strong negative. And let's get the next one. This next one, you can't tell if it's increasing or decreasing. So this one would be considered just a scatter plot with no correlation. E is going from left to right. Looks like it's rising slowly. A lot of points are close to that line, so that would be considered a strong positive. Strong positive correlation. And then the last one here, let's take a look. It looks like it's decreasing. And so although it's decreasing, a lot of points are away from the line, so this is considered a weak negative. A weak negative correlation. So looking at our value where R is approximately -0.3, and if you wanted to remember again your number line that we just made between -1, 0, and 1, that -0.3 is going to be closer to 0, so that's going to consider a what? A weak correlation, right? So a weak negative would be graph F. So your answer for this one would be F. To calculate the correlation coefficient, we have this ominous formula for you to use. And it is R is equal to everything. All right, so back in the day, we actually had to use this formula and calculate everything by hand. All right, thankfully nowadays we have a calculator. If we put in the data set incorrectly, it will give you a very close approximation, which is what we use today. Now, you are going to be using, and I just said a graphing calculator, but it's not. It's going to use the calculator. We're using our Casio 115 ES Plus. And the instructions for this are on document sharing on my math lab. So you go to my math lab, click on course tools, go to document sharing, and you'll see the calculator instructions. Also, you want to take a look at the chapter 11 and 12 notes, also on document sharing. So thank goodness we don't have to do this by hand. We're going to use our calculator. So this says to compute R, the correlation coefficient, using the following data. So once again, you have to remember the X and the Y's, those are ordered pairs. So for this first point, this is 8, 8. All right, I'm going to write the instructions for the calculator down just so you have it in this notes. So we have mode. Get your calculator, you're going to press mode, then number 3. Press number 2. And the 2 should have an A plus BX by it. Then you're going to enter your data. You're going to enter the X values, press your equal to, it'll drop down to the next number, and then you go up and enter your Y values. Once you are done entering each of your values, the next thing you want to do is press AC. There's a button on that calculator that says AC, and this is so important. This is to save the information that you just entered as your data. All right, so after the calculator has saved your data, you're going to go into Shift and press number 1, Shift number 1. Press number 5, which should have an REG for regression next to it. And you're going to have the option on there. There's going to be some letters, and you have the option to choose R on here. You're going to get, I believe it says A plus BX regression line, which is what we will do a little bit later in this lecture, is to find the regression line. Or you can choose the R on there. So you can find A, or you can find the B, or you can find the R, which is your correlation coefficient. So after putting this data in, you calculate this, and the answer on here, it says round to 3 decimal places. So what you should come out with on your calculator would be 0.92148, depending on how many numbers your calculator will show. We're going to round to 3 decimal places. So our correlation coefficient is about a 0.921. All right, so let's think about that. 0.921. Again, correlation coefficient falls between -1 and 1. Here's my 0. And that positive 9.21 is going to be real close to the number 1, right? So this is considered a strong positive correlation. So as X increases, Y increases. All right, so make sure you go over to my math lab and look at the calculator notes and understand how to input this data. Let's try this application problem. So it has a few steps on there for us. The thing you need to look at is our chart, and it is measuring generation. We have our generation of individuals, and then we have percentages of who won't try sushi. That is our X variable. And then we have who don't approve marriage equality, and that is your Y variable. So the first thing we need to do is go to our Casio calculator and calculate the correlation coefficient. This is part A, determine the correlation coefficient. So once again, I have the directions on the right-hand side. You're going to press mode 3, press number 2, enter your data. Now, when you enter your data, you're going to press all the X values first, press 38, your equal sign, 52, equal sign, and so forth until you get to 77, press your equal sign. Then you use that center button where it has the arrows, you move to the right and scroll back up to the very first Y value, enter your Y values, 34 equal, 45 equal. Go all the way through till you press 70 equal, and then after you press that last equal, go ahead and press AC to save your data. Very important that you press your AC. So your data is all saved in your calculator at this time. Next, we're going to hit Shift and 1, press the number 5, and then you'll see some options on there. We're going to be choosing R, A, or B in this exercise here. So we're going to choose R for this part A. Follow it by an equal sign. It'll divert you back to your home screen and it'll give you a calculation for R. So when I tried working this one, I ended up with R is approximately 0.991310. That's what it looked like, 99310. And when we round this, it does tell us to round to 2 decimal places. We're going to get that R is approximately 0.99. All right, so 0.99 is really close to the number 1. So this is a strong positive correlation. All right, so in my math lab, you're going to put in 0.99. It'll also take the 0.99. All right, so next it says, what explanations can you offer for the correlation coefficient? So remember, when it's a strong positive, it's telling you that as X increases, Y also increases. It's in a positive direction. So if you read through this, the best option on here is A. It says an unwillingness to try sushi and disapproval of marriage equality have a strong positive correlation. And we're getting that from our correlation coefficient. So my answer here would be A. All right, so for part C, it says find the equation of the regression line for the percentage who won't try sushi and the percentage who don't approve of marriage equality. So you can see on here, it says y is equal to blank x plus blank. Round to 2 decimal places as needed. So once again, we're going to go back to the second part of our instructions where it says shift 1. So press shift 1, number 5, and then you can choose A or B. If you choose A, option A is coming out to, it looks like, when you do your approximation and rounding, a negative 1.67. And then we do this again. Shift 1, number 5, and go find your answer for B. And B is rounding to 0.94. All right, so this equation over here is actually written as y is equal to bx plus a, which follows your calculator. So what they want is the equation of a line that is using your data values. So all we're going to do is rewrite this as y is equal to 0.94x. Let me make that look like an equal sign. Minus 1.67. And that will be your equation of the line. So that's your linear regression line. That is the line of best fit. The line that goes through as close as possible to your data values, your X and Y values. All right. So now that we have our equation of the line, our regression line, let me go ahead and put a little box around it so you can see where I'm at. We're going to go to the next part. Part D says, what percentage of people can we anticipate do not approve of marriage equality in a generation where 23% won't try sushi? All right, so remember, If you look at the top chart there, this is a percentage. All these values are percentage. So when they're saying the part that 23% won't try sushi, all we're doing is substituting in the value 23 in for X into the equation we just created. All right, so this is going to give me Y is equal to 0.94 times 23 minus 1.67. All right, and when we calculate that, that gives you something like 19.95. And this will approximate to the number 20. It does tell you in the instructions to round to the nearest percent. So we are going to place the number 20% as our answer. So this refers to example 2 in the textbook, and it's saying that when we calculated our correlation coefficient, we came out with a negative 0.92. The sample size is 10, and it says, can we conclude that there is a negative correlation between education and prejudice in the population? So if you look in the solution region right here, it says if you take the absolute value of the correlation coefficient, we are going to get a result of a positive 0.92. So we're taking this absolute value of R, and we are going to compare it to the results in the chart that fall with the sample size of 10. Right, so we're looking at this 0.632 and 0.765. And it says on here, because 0.92 is greater than both of those values, you can conclude that a correlation does exist between education and prejudice. All right, so the absolute value of the correlation, if it is greater than the values on the table, then there is a relationship, a correlation between the two X and Y values. Let's carefully read this one. The correlation coefficient R is 0.39 is given for the sample of N equals 4 data points. Use the alpha 0.05 column, so that would be this first or second column right here, in the figure shown below to determine whether or not we may conclude that there is a correlation and if it exists in the population. All right, so remember what we're looking for is the absolute value of R greater than, and let's go find our value from the table. So we know N is 4, so we're looking under the alpha is 0.05. We want to know if the absolute value of R greater than 0.950. Again, I got that from the table using N as 4. All right, and so when we go in and take the absolute value of R, we get 0.39. And is 0.39 greater than 0.95? The answer is no. And so since it is not true, we can say that the correlation does not exist. So if R is greater than the value on the table, there is a correlation. The absolute value of R is not greater than, there is no correlation. And they already gave us the answers down below. It says 0.39. Is it greater than? The answer is no, and we finished that out with no correlation. All right, so this concludes our lecture on Chapter 12.